Hello friends, welcome to our channel IPMAT. Today's video lesson is on one of the most important concepts in maths. We are going to cover the basics of ratios through 6 different questions of an increasing difficulty level. These questions have a similar theme though. They are all based on ropes. In this process of solving various questions, we will also have a look at how to simplify and combine ratios. Because if you know these simple tricks, the related questions become super easy to attempt. So keep a pen and a notebook nearby and do try to attempt all the questions on your own as we go along. Let us begin. Our first question is, a rope of length 77 meters is cut into 2 pieces such that the length of one of the pieces is 4 by 7 times the length of the other. Find the length of the shorter piece. On the face of it, it doesn't look like a ratio question, does it? So a beginner would perhaps attempt this question in the following manner. Assuming that the length of the 2 pieces are A and B. Now to find the values of these 2 variables, we will need 2 equations, right? We can utilize the following 2 conditions given in the question for this and write 2 linear equations based on these conditions. Once we get 2 linear equations in 2 variables, solving them together is no big deal. We can find the values of both variables and this is how the solution plays out. The shorter piece, which is our required answer, is 28 meters. However, I promised that I'll be teaching you ratios. So let me tell you a better method through which you will understand the concept of ratios right from the beginning. You would also understand the importance of ratios and how the concept is to be applied to such questions. Let us pick the condition. The length of one of the pieces is 4 by 7 times the length of the other. A is equal to 4 by 7 into B is the same as saying that A upon B is equal to 4 upon 7. In the language of ratios, we can rephrase the same equation as A ratio B. We read it as A is to B is equal to 4 is to 7. Please note that A is to B is the same as the fraction A upon B when expressed in the simplest form. So 4 is to 7 is the same as the fraction 4 upon 7. What is the use of a ratio? A ratio is a comparison between 2 or more quantities. If A is to B is given as 4 is to 7, this implies that if A were 4 units in length, then B would be 7 units in the same context. This means, in our question, A is the shorter piece of the rope. Now there are a lot of things that we can do with this equation. For instance, we can multiply the numerator and denominator by any arbitrary constant. As long as we multiply numerator and denominator by the same quantity, we know this equation would hold because our constant k would get cancelled out, right? So the second most important learning in this chapter is that if a ratio is given, then the 2 original quantities can be assumed in terms of a single variable. This means instead of taking 2 different variables A and B like we did in the previous approach, we can assume A as 4 into K and B as 7 into K. The choice of the variable is completely yours. You can take X, Y, Z or alpha, beta, gamma, whatever you wish. So what is the benefit of doing so? To put it simply, if there are 2 variables in the system, you would need to solve 2 equations to get their value. But using the information given in the form of a ratio, we can reduce the same system to a single variable. And a single variable means only a single equation needs to be solved, which is much simpler for both you and me, isn't it? Okay, so did you realize this is the same question? And let us solve it now using a simpler approach. The ratio of lengths of the two pieces is given to be 4:7. Using this ratio, we can assume their lengths as 4K and 7K. Also, clearly, A is the shorter piece. The question says that the total length of the rope is 77 meters. So 4K plus 7K is equal to 77. 11K is equal to 77. Therefore, K is equal to 7. Once we get the value of our variable K, I can solve for any of the required lengths. I can find out anything. So find the length of the shorter piece. A is the shorter piece, which is 4 times K in length. K we found out is 7 and 4 into 7 calculates to 28. So our required answer for the length of the shorter piece is 28 meters. Let us try out one more question to understand some other basic things about ratios. So question number 2 says that the ratio of length of rope A to the length of rope B is 5:3. If each of these ropes were 7 centimeters shorter, the ratio of their lengths would then be equal to 2:1. Find the difference in lengths of the two ropes. A is to B is given to be 5:3. Therefore, we can assume the length of rope A as 5 into K and length of rope B as 3 into K, both in centimeters. If both ropes were 7 centimeters shorter, the new lengths of the two ropes would be 5K minus 7 and 3K minus 7. The ratio would then be 2:1. We can write this information in the form of the following equation. Since A is to B is the same as A upon B, the ratio of new lengths of these two ropes can be written as 5K minus 7 upon 3K minus 7, which is equal to 2 upon 1, which is the same as the ratio 2:1. Cross multiplying both parts of this equation, we get 5K minus 7 is equal to 2 times 3K minus 7. We collect all terms involving variable K on the left hand side. 6K minus 5K is equal to 14 minus 7. Therefore, the value of our variable K is 7. Now the difference in lengths of the two ropes A and B is equal to 5K minus 3K, which is equal to 2K, and K is equal to 7. So 2K will be equal to 2 into 7. That is 14, and that's our answer. Now, many of you might be having a very legitimate doubt at this stage that if we can assume the original lengths of rope A and rope B based on the ratio 5:3, why can't we assume the final lengths based on the ratio 2:1? Let me clarify this doubt. We can very well do that. Just as we assumed the initial lengths of the two ropes as 5K and 3K, we can also assume the final lengths of the two ropes as 2K dash and K dash based on the ratio 2:1. Just make sure that you don't take the same variable K again for the second ratio. Take a different variable. If two different ratios are given, we must always take two different variables to assume the respective quantities if need be. So in this alternate method to solve the same problem, how do we go about finding our answer? Well, the difference in initial lengths and final lengths is 7 centimeter for both ropes. So this minus this is 7, and so is this minus this. Therefore, we can write this condition in the form of an equation. 5K minus 2K dash is equal to 7, which in turn is equal to 3K minus K dash. This is equal to this. So collecting all terms with variable K on the left hand side and the variable K dash on the right hand side, we get 2K is equal to K dash. So see, if we had taken the same variable, we would have done a mistake. We use this value of k dash in our original equation to get 3k minus 2k is equal to 7. Therefore, the value of k is 7. Our required answer, the difference in lengths of the two ropes will be 5k minus 3k, which is equal to 2k. 2 into 7 is 14. Frankly, the earlier approach is easier, but I prefer this approach because less calculations are required in this one. Next question is, a piece of rope was cut into 3 pieces in the ratio of 4:3:2. The difference in length between the longest and shortest is 24 centimeter. Find the length of the longest piece. In this question, we have 3 ropes instead of 2. However, the ratio basics remain the same. This single ratio gives us a comparison of all 3 pieces in one go. Basis this ratio, we can infer that if the length of the first piece is 4 units, then the length of the second piece will be 3 units and length of the third piece will be 2 units. Let us assume the lengths of the 3 pieces as 4k, 3k and 2k. This is clearly the longest piece and this one is the shortest. In any question on ratios, we must solve for the value of our variable k first. So we use this condition that the difference in lengths of the longest and shortest piece is 24 centimeter. In an equation format, it looks like 4k minus 2k is equal to 24. 2k is equal to 24. So dividing by 2 on both sides, k is equal to 12. Length of the longest piece is 4 times k. 4 into 12 is 48. And that is our answer. Now for many questions in ratios, we must combine 2 or more ratios and find a single ratio which gives a comparison of all the involved quantities in one go. If we do that, it makes solving that question much more simpler. Let us take an example scenario where some toffees are distributed between 4 students, A, B, C and D. So if A gets 32, B gets 24, C gets 16 and D gets 20 toffees, find the ratio of the toffees received by these 4 students. As given in the statement, we write A as 32, B as 24, C as 16 and D as 20. And rest assured, this is our required ratio. We just need to simplify it a little. So remember, just like we multiplied all parts of the ratio by an arbitrary constant k to assume the original quantities, we can also divide the original quantities by any constant to get our ratio, isn't it? To simplify a ratio, we can either divide or even multiply all parts of that ratio by the same constant. In doing so, the relative comparison of those 4 quantities does not change. So to simplify this ratio, let us look at the common factor of these 4 quantities. I can see that one of the common factors is the number 4. So let us divide all 4 of them by the number 4. 32 divided by 4 is 8. 24 divided by 4 is 6. 16 divided by 4 is 4. And 20 divided by 4 is 5. Now we can see that there is no single number which is common to all 4 of these. So we have obtained our ratio in the simplest form. What if A gets half, B gets 1/3, C gets 1/9 and D gets 1/18 of the lot? For our required ratio, we write these fractions first. A is half, B is 1/3, C is 1/9 and D is 1/18. We need to simplify it further. So let us try to find out a common number that is to be multiplied with all of these fractions. Let us look at a common multiple of all denominators. 2 and 3 A common multiple is 6, 6 and 9. A common multiple is 18. And the last number is already 18. So common multiple of all denominators would be the number 18. Let us multiply all four of these fractions with the number 18. Let us see what we get. Half into 18 is 9. 1 by 3 into 18 is 6. 1 by 9 into 18 is 2. And 1 by 18 into 18 is 1. So the ratio when expressed in simplest form will be 9:6:2:1. In the next question, they have given us the following information. If A gets 2/3 of what B gets 3/4 of what C gets, and C gets 6 by 5 times what D gets, we need to find the ratio of the toffees received by all four of them. So first we write this information in an equation format. A is equal to 2 by 3 into B, and rearranging the terms we get A is to B as 2 is to 3. B is equal to 3 by 4 into C. This means B is to C is equal to 3 is to 4. And C is equal to 6 by 5 into D. This means C is to D is equal to 6 is to 5. If we need to find the ratio A is to B is to C is to D, we must combine these three ratios one by one. Combine any two of them first. Just make sure one of the quantities should be present in both of them. So let's combine the first two ratios. A is to B is 2 is to 3 and B is to C is 3 is to 4. B is the common quantity in these two ratios. So our objective is to make the value of this quantity, B, the common quantity, equal in both ratios. Luckily, in the first ratio, B is equal to 3 and in the second ratio, B is equal to 3 again. When we combine these ratios, we should make sure that the original ratios also hold. Since B is equal to 3 in both, we copy 3. A is to B is 2 is to 3. So A will also remain the same. We copy 2 for the value of A. And B is to C is 3 is to 4. So C will also remain the same. We copy 4 for the value of C. Next, we combine this ratio C is to D with the ratio we just calculated, A is to B is to C. We take help of the common quantity in these two ratios, which is C. In the first ratio, C is equal to 6, while in the second ratio, C is equal to 4. We need a single number for C. We need to equate C in both ratios. So let us take a common multiple of 6 and 4. Lowest common multiple of 6 and 4 is 12. So our objective is to make the value of C equal in both. Make it 12 in both ratios. For this, we can multiply all parts of this ratio by the number 2. 6 into 2 is 12 and 5 into 2 is equal to 10. Remember, as long as we multiply or divide all parts of a ratio by the same constant, the ratio remains the same. And we multiply all parts of this ratio by 3. 2 into 3 is equal to 6, 3 into 3 is equal to 9, and 4 into 3 is equal to 12. Now C is equal to 12 in both ratios, so we may combine them. A is to B is to C is to D is equal to 6 is to 9 is to 12 is to 10. And finally, if the toffees were to be distributed such that 4 times the toffees received by A is equal to 3 times the number of toffees received by B is equal to 2 times the number of toffees received by C is equal to 6 times the number of toffees received by D, which is what this equation means. How do we find the combined ratio? Well, in such questions where I spot more than one equal to sign, there is one simple step I always do. I take everything equal to an arbitrary variable, say k. So 4a is equal to k, a is equal to k by 4. I jot down the value of a in terms of k. 3b is equal to k, b is equal to k by 3. I write that value here. 2c is equal to k, c is equal to k by 2. I write that here. And 6d is equal to k, d is equal to k upon 6. I write that value of d here. To simplify, I first divide all quantities of this ratio by k and I get this. Next, I multiply all quantities by LCM of 4, 3, 2 and 6, which are the denominators of these fractions. Their LCM is 12. 1 by 4 into 12 is 3. 1 by 3 into 12 is 4. 1 by 2 into 12 is 6. And 1 by 6 into 12 is 2. Hence, our answer is 3:4:6:2. Now let us apply what we have learned so far to the question on your screen. The ratio of length of rope A to the length of rope B is 4:3. The ratio of length of rope B to the length of rope C is 6:5. If the total length of all the three ropes is 57 cm, find the length of the shortest rope. Looking at the two given ratios, I can easily infer that C is the shortest rope. Do you know why? 4:3 means A is greater than B and 6:5 means B is greater than C. That means A is greater than B is greater than C and C is the shortest rope, isn't it? But to use this condition, total length of all the three ropes is 57 cm. It would help if I have the combined ratio of lengths of all three ropes A, B and C. This question is very similar to question number 3 in that respect. So let us combine the two ratios first to find the respective lengths of rope A, rope B and rope C. A is to B is 4:3 and B is to C is 6:5. B is the common quantity in these two ratios, so we should make it equal in both ratios. B is 3 in this ratio and 6 in this ratio. LCM of 3 and 6 is 6 obviously. So let us multiply the first ratio by 2. 4 into 2 is 8 and 3 into 2 is 6. Now B is equal in both ratios. So the combined ratio A is to B is to C will be 8:6:5. Next, the lengths of A, B and C can be assumed as 8K, 6K and 5K. Total length of these three ropes is given to be 57. So we write 8K plus 6K plus 5K is equal to 57. 19K is 57. So the value of K is 3 cm. Shortest rope is obviously C as we discussed earlier and C is equal to 5K. 5 into 3 is 15. So the length of the shortest rope is 15 centimeters. Fifth question is also similar to question number 4. We have some options as well. You might try solving the question on your own and pause the video if you wish. Once you are done, let's discuss. So the question is, the ratio of lengths of rope A to the length of rope B is 3:4. The ratio of length of rope C to the length of rope B is 7:6. If the length of longest rope is 84 centimeters, find the total length of all three ropes. Combined ratio of all three ropes would help. So let us combine the two ratios first. A is to B is equal to 3:4 and C is to B is 7:6. B is the common quantity in these two ratios which needs to be made equal for both. B is 4 here and 6 here. LCM of 4 and 6 is 12. To make B 12 in both ratios, we multiply this one by 3. 3 into 3 is 9 and 4 into 3 is 12. And we multiply this one by 2. 7 into 2 is 14 and 6 into 2 is 12. Therefore, the ratio A is to B is to C will be 9 is to 12 is to 14. So let us suppose the lengths of the three ropes are 9K, 12K and 14K respectively. Clearly, this rope of length 14K is the longest. And it is given in the question that the length of longest rope is 84 centimeter. This will help us find the value of K. 14K is equal to 84. So K is equal to 84 divided by 14, that is 6. Total length of three ropes will be 9K plus 12K plus 14K, which is equal to 35K. K is 6. So 35 into 6 will be 210 centimeter. And that is our answer. And finally, this is one question you all can easily attempt if you have followed all concepts covered in this video attentively. 3A is equal to 4B is equal to C is equal to 2D. This equation gives me a hint that A, B, C and D should all be expressed in terms of a single variable, say C. So 3A is equal to C, that means A is equal to C upon 3. 4B is equal to C. B is equal to C upon 4. C is C itself and 2D is equal to C. D is equal to C upon 2. LCM of 3, 4 and 2 is 12. Multiply all quantities of this ratio by 12. We get the combined ratio as 4 is to 3 is to 12 is to 6. Basis which we can assume the lengths of the four pieces as 4K, 3K, 12K and 6K. Clearly, this is the shortest piece and this is the longest piece. But to find out their difference, we need to calculate the value of our variable K first. We use the condition that the length of the initial rope was 7.5 meters, or we can say 750 centimeters. Let us add up the lengths of all pieces. 4K plus 3K plus 12K plus 6K is equal to 750. 25K is equal to 750. Therefore, K is equal to 30. The difference in lengths of the shortest and the longest piece will be 12K minus 3K, which is equal to 9K. 9 into 30 is equal to 270 centimeter. So that is our answer. That brings us to an end of this video lesson. Hope you have understood the concept of ratios well. If you found the lesson useful, don't forget to press the like button and also share with your friends. Here is a glimpse of other popular maths videos on our channel. Subscribe our channel IPM Leap to watch more. Take care everyone. Bye-bye.